7.3 Properties of Kites and Trapezoids. Students will learn the properties of kites and trapezoids and will be able to solve for the unknown sides and angles of these polygons. Trapezoid is a quadrilateral with exactly one pair of parallel sides. This part is important, exactly one. It cannot have two. Okay, the parallel sides are called the base, or bases. The non-parallel sides are called the legs. An isosceles trapezoid is a trapezoid with congruent legs, or sides. You can see from this picture, this side is congruent to this side. Another characteristic of an isosceles trapezoid is that this angle is congruent to this angle. The midsegment of a trapezoid, so the midsegment, as we learned from triangles, means that E is the midpoint of AB and F is the midpoint of CD, and if I connect those two together, it's parallel to the base, both bases, and it's also 1/2 the length of BC plus AD, which means I average. I take BC plus AD and divide by 2, and that will give me the length of EF. So, correct definition is not really 1/2 the base averages, it's the base averages. That's how we find the base averages. We add them together, divide by 2. I'll wipe that out. So it's technically correct. So let's talk about the properties of a trapezoid. It has one pair of parallel sides. So trapezoid is also in the quadrilateral family. If you'll turn really quick to 7.6 notes again to this picture here, the flow chart. A trapezoid is in the quadrilateral family, and we're going to draw it right here. Remember, a quadrilateral is a four-sided polygon. So all of these things that we're talking about are special quadrilaterals. Okay, and you'll notice under trapezoid is an isosceles trapezoid. We're going to talk about that today too. So trapezoid has one pair of parallel sides and only one pair of parallel sides. This one looks like a nice little trapezoid, but a trapezoid can also look something like this. It just has to have one pair of parallel sides here. Okay, and then an isosceles trapezoid has the base angles are congruent, and then the legs are congruent. So these two legs are congruent to each other. On an isosceles trapezoid, the diagonals are also congruent. So if I drew a diagonal from here, and I drew this one from here to here, then those two lengths are the same. So if I had A, B, C, D, I would say AC is congruent to DB. So the properties of an isosceles trapezoid. Not every trapezoid has these properties, but an isosceles trapezoid, one with congruent legs, has these properties. Okay, we're going to talk about, next one is a kite. So go back to your 7.6, and I want you to fill in right here, a kite. This is another type of special quadrilateral that we're going to talk about. So a kite is a quadrilateral with two pairs of consecutive congruent sides. Think about what that means, consecutive congruent sides. We'll talk about that in just a second. But the opposite sides are not congruent, so that's different from a parallelogram. A parallelogram, a rectangle, a rhombus, and a square all had opposite side congruent. A kite is not. So let's think about what consecutive congruent sides. That means that this side and then the side next to it, there, are congruent. And then this side is congruent to this side. And if you look at a kite or remember them from when you're a kid, that kind of makes sense. That's what it looks like. Okay, and then the opposite, one pair of opposite angles are congruent. So it's the angle that comes between the different sides. So this is kind of like a small side and big side, we can say. So that means this angle and this angle are congruent. The diagonals on a kite, even though mine looks really bad, freehand drawing here, but they are perpendicular, so they will meet at a 90-degree angle. Remember when you were a kid and you had a kite, these are the sticks on the back, and they always looked perpendicular to each other. The diagonals of a kite also, they bisect each other. So if I have this diagonal, this would be this diagonal. So not only are they perpendicular, but they bisect each other. So this is congruent to this, and this is congruent to this. Diagonal bisects non-congruent angles. So if you'll remember, my congruent angles were these two. So the diagonal bisects the non-congruent angles, which means that this side is congruent to this side, and then it cuts this angle in half. So this angle would be congruent to this angle. Okay, remember that the congruent angles are the angles that come between the two sides that are not the same. So since this side is not the same as this side, the angle between them is a congruent angle to the one opposite. Okay, so let's do some examples. Given triangle, or ABCD is a kite, determine the length of segment CD. So I'm looking for this one. Now remember, this is a 90-degree angle right here. So I have this little triangle, looks like this, and I have 3, 5, and x. Pythagorean theorem. 3 squared plus 5 squared equals x squared. This is 9 plus 25 equals x squared. So this is square root of 36, which we know is 6. So CD is 6. That means that AD is also 6 because the properties of a kite say that these two sides are the same. Right there and right there. Okay, now I need to find DB and AC. Well, DB, I just have to add 5 plus 7. That's not too bad. So DB equals 12. And then AC, if this side is 3, remember the diagonals bisect each other, so this would also be 3. So the full length is 6. Okay, 2, find the perimeter of the kite. So once again, if you notice, I have a 90-degree angle here. So I'm going to pull that triangle out, make it easier to see. I have a 12. This says it's 10. And I need to find this length right here. So I'm going to have 12 squared plus 10 squared equals x squared. So it's 144 plus 100 equals x squared. So I can square root both sides. And I get the square root of 244. And I'm going to put this as a decimal just to make it a little bit easier here to find the perimeter. So the square root of 244 is 15.6. So this length right here is 15.6. Okay, now that tells me what this length is, but I don't know how to find this length down here. So this tells me right here this is 26. Once again, I have a right triangle. I go like this. 26. This is 12. Using this triangle right here. And I can say 12 squared plus 26 squared equals, I can call this x again, x squared. 12 squared is 144. And then 26 squared is 676. So x is going to be the square root of 144 plus 676, which is 820. And then the square root of 820 on the calculator is 28.6. So this is 28.6, and this is 28.6. So if I add all of those together, I have 15.6 plus 15.6 plus 28.6 plus 28.6, and I get 88.4. I'm kind of running out of room here, but I'm going to write perimeter equals 88.4. Okay, Given trapezoid A, B, C, D, find the other angles. Notice this is an isosceles trapezoid because the two legs are congruent. So if this is 73, then this is 73. If we remember the properties of a quadrilateral, the interior angles of a quadrilateral is 180 times the number of sides minus 2. So 180 times 2 on a quadrilateral is 360. Okay, so I need to find the measure of these two angles up here. On a isosceles, okay, I'm back. Sorry, had to answer an important phone call. So this is an isosceles trapezoid. So if these two angles are congruent, then on an isosceles trapezoid, we didn't really talk about this property, but that means that these two angles right here are also congruent. We should have marked that on our first page. So if it all has to add up to 360, and I know I have 73 plus 73 gives me 146. I can take 360, subtract 146, and I'm left with 214. Now 214 has to be divided evenly among those two. So I can just divide it by 2. And that means that angle B equals 107 and angle C also equals 107. Okay, number 4. Now we got to kind of think about what we know about parallel lines and a perpendicular line. So if this line right here is parallel to this line, because it tells me it's a trapezoid, so I know it has to have one set of parallel lines, I can obviously tell that those two are not parallel. So this is parallel to here. If this line is perpendicular to this line, then it must also be perpendicular to this line. That's kind of my same side interior angles theorem as well, that they're going to be supplementary. So if one is 90, the other one has to be 90. The interior angles of a quadrilateral has to add up to 360, so I have 90 plus 90 is 180 plus 112. I get 180 plus 112 is 292. So I can find my missing measure by taking 360 minus 292, and it's 68. So angle D equals 68. Okay, number 5 says, Maria told Sam that an isosceles trapezoid must also be a parallelogram because there is a pair of congruent sides in an isosceles trapezoid. Is Maria correct? Explain. The answer is no, because an isosceles trapezoid has exactly one pair of congruent sides. It doesn't say that it has at least one, it says exactly one. And a parallelogram has to have two pairs. So, given trapezoid ABCD, find x. Now this was when we had to average the bases. So to find average, I add them together. 8 plus 12 is 20. And then when I find average, that means I have to divide by 2. So that means 10. And if that makes sense, because the middle between 8 and 12 is 10. So x would be 10. Now number 7, I can kind of look at this and think, well, if this is 30 and this is 24, the difference here is 6, right? That means that the difference on this one is going to be 6. So 24 minus 6 is 18. So 4x plus 2 has to equal 18. If I subtract 2 from both sides, 4x equals 16, divide by 4, and I get x equals 4. Now, that's not the only way to solve this problem. It's just one of the quickest ways to notice. One that gets a little bit hairier is to say, well, I know I have to take the average of the bases, and it has to equal 24. So I can say 4x plus 2 plus 30, and then I'm going to divide that answer by 2, or I can take 1/2 of it. Same thing. That has to equal 24. You can see why this is kind of the harder way to do this, but to get rid of this fraction, I can multiply both sides by 2. So I can have 4x plus 2 plus 30 equals 48. Combine like terms. 4x plus 32 equals 48. Now I'm running out of room, so I'm going to go up here and say, I'm going to subtract 32 from both sides. So 48 minus 32 is 16. So 4x equals 16. Divide both sides by 4x equals 4. So it worked out both ways, right? Sometimes if you can look at a picture and look at it intuitively, it might save you a whole bunch of work here. Okay, and to sum it up, we've got determine whether each statement is true or false. If false, explain why. A square is also a rectangle. Let's look back at our diagram here. So a square is actually a special kind of rectangle. It means it has all the properties of a rectangle plus one more. And that one more is that the sides are all congruent, which makes a few other things, like the diagonals are perpendicular and that it cuts the vertex angles in half, also true. So a square is a rectangle. That's true. Then we have, oh, this is the back of 7.6 notes. Hey, I got you started though. That's all right. So let's skip for 1 second. So 7.6 is kind of what we're going over. So I'm sorry, I kind of threw in a page there. You probably were wondering where I was getting that. This is where I was. So we summed up the quadrilateral family is what we've been talking about the last few days. So we have quadrilaterals. That breaks into three things: trapezoid, parallelogram, and kite. Trapezoid breaks down into isosceles trapezoid. A parallelogram breaks into rectangle and rhombus, and they both break down into a square. And then we have kite over here by itself. So on the rest of 7.6, you're supposed to sum up all the properties that you know. Now, I've already filled mine out, and you can use your notes to do this, but I want you to pause this video and try to fill in all the properties of all of these quadrilaterals. And I'll wait just a second so you can pause it, and then you're going to come back and check your answers with mine. Okay, here's the answers. And each of these answers can be explained by looking back at your notes. One thing I did say, one pair of sides are congruent and parallel. I kind of changed this one because there was nothing that fit that one pair of sides are both congruent and parallel, because parallelograms, rhombuses, rectangles, and squares all have two pairs. And a trapezoid has one pair that's congruent, but it's not congruent and parallel. So nothing really fit that definition. So I crossed this out and changed it. That it has one pair of sides are congruent and parallel, and one side is parallel. That's an isosceles trapezoid. Hope that makes sense. Diagonals are congruent. This one's true on an isosceles trapezoid, and then these other things. But not just any trapezoid. It has to be isosceles. Okay, so hopefully you can kind of sum up your answers. If I'm going too fast, go ahead and pause the video and fill it in and try to digest. This would be a good page to study. So then we come to this page I already started. A square is also a rectangle. That's true. The base angles of a trapezoid are always congruent. That's only true on isosceles, so that's false. It's true for isosceles. Okay, and the diagonals of a rhombus bisect each other. That was true. You can look back on our properties to see that. And a parallelogram is also a trapezoid. That is false.